All right, good morning, everybody. So today we're going to be taking the notes 4.1, where we're going to be talking about polynomials and all the different things that a polynomial function has. So as you can see on the notes here on page 2, polynomials are basically a monomial or a sum of monomials where the exponents are whole numbers and the coefficients are real numbers. And that's the biggest thing to notice here. The exponents need to be whole numbers, and of course, our coefficients are real numbers, no imaginary stuff like we did a couple weeks ago. Um, and so when we're looking here, they're basically saying, look at all your powers. When you're looking at your powers, powers are positive and whole numbers. So no fractions, no decimals, no negatives, like it says, right? It has to be a positive. So when I'm looking at all my powers here, look at this example. There's a 3, a power of 2, and of course, a power of 1 that's usually invisible. This is how we recognize a polynomial function. Again, there's no x at the bottom of a fraction because that would mean that it's a negative power. Um, all of these are positive and no fractions or decimals involved. That's why this is a perfect example of a polynomial. The next vocab word that we have here says, all right, we're going to talk about a degree. Well, a degree is the highest exponent in the polynomial. Now, when you're looking at the highest exponent in the polynomial, be careful. They might write the polynomial in not in descending order. So we'll say it's in the incorrect order, but that's why we have to watch out for it. And if you look here, it goes power of 3, power of 2, power of 1, which is why the degree, as it says here, is a 3. The degree of the entire polynomial, it doesn't matter that there's other powers there, would be just a 3. And finally, the last vocab word that we have here is leading coefficient. So this is the number written in front of the variable with the largest exponent. So the thing is, and that's why order is important, this right here is your leading coefficient. It's the number written in front of the variable. But again, it has to be the variable with the largest exponent. So this leading term that we like to call the leading term kind of calls the shots as to what this graph is going to look like. So for instance, we have a couple of different common polynomial functions here, some that we've seen in our past before. So for instance, this one that says 0 degrees, if it has a degree of 0, meaning it's a constant function, the reason it's a degree of 0 is we don't see an x here. If we were to write an x there, I would have to write it like this. F of x is equal to 3, x to the 0, but that wouldn't make sense for us to write. That's why we just write the 3. So in this case, we would go up to 3 here. And as always, we've already learned that this is just a horizontal line. It goes side to side. F of x is equal to 3. So there's an example of a graph there for you. Now, looking at the next one, look at number 1. It says, well, what if you have a linear function? Well, it says if you have a linear function, you have to have a power of 1. And so in this case, here's that invisible power that we're talking about. That's how we determine that this is a degree of 1. And if we're talking about the graph of this, let's see, I have a y-intercept of 0, and then I go up 3 and over 1. And just like that, we have our traditional line that looks like this. So obviously, if we have a horizontal line, my degree is 0, right? A power of 0. A degree of 1, a power of 1 has always been linear for us. And then, of course, here we have a quadratic function. A quadratic function we recognize because it has to have a power of 2. And so as I'm looking at these powers of 2 here, I look at this, and yes, this is in the correct order. It's in descending order. Look at my powers, power of 2, power of 1. But this is the one that calls the shots. Nothing else really matters right now, but this is the one calling the shots. This is what tells me that we're dealing with a quadratic. And as we've mentioned before, look at that leading coefficient, right? My degree, we already said, is 2, but my leading coefficient is 3, and it's a positive 3. So we know it's going to be a happy parabola, as we've mentioned before. So we're just going to do a random sketch here. So there you go. We'll just do something like this. But look, what we have a happy parabola, a parabola that opens up as we've done in the past. But now we're going to get into some functions that we haven't really worked with before. And if we had the time, or if I was in class, we would obviously do this with Desmos to get a better look at these graphs. And by the way, I forgot to say the leading coefficient here was 3, right? Even though the degree is 1, we already had the degree on this side. But look at this one. So this is new to us. It's called a cubic function. And when you have a cubic function, look at the powers, 3, 2, 1, power of 0. This is in perfect descending order, which is what we want to see because this is the one that calls the shots as to how this polynomial is going to behave. And again, it's a polynomial because all my powers are positive and they're whole numbers. Well, we already see it here. This is a degree of 3 because that's the biggest power we have. And even though it has 4 terms, the lead coefficient, see, we're going to cut it short there, is a 3 also, so just a coincidence there. But the idea is anytime you have a cubic function, we have to think of it this way. It's heading down in one direction, right? A parabola heads in the same direction on both ends. But here, we might have not a parabola, but we have this type of function. Students in the past have called it, oh, it's the snake function, right? Whatever you want to call it. But the idea is when you have a cubic function, notice how it ends. A parabola ends by going in the same direction. A cubic function ends by one going to one side and then one going to the other. One is rising, one is falling. While in a parabola, they're both rising. And so this is a cubic function. And then we get to something we call a quartic. Now, when you have a quartic, again, let's look at the powers, power of 4, 3, 2, 1, 0. This is in perfect order. The degree, of course, is, remember, this one calls the shots. The degree is 4 for the entire thing. That's who's calling the shots on how the graph is going to behave. And then the lowest coefficient, the leading coefficient is the number 3, and it's positive. So check this one out. If you have a chance on Desmos and you try to type this in so that you can see what it looks like, I'm just going to give you a rough sketch, a random sketch of this thing. But here's what we know about something that has a power of 4. It's going to go up. It's going to rise to the left and then to the right. Because it's an even power, it's actually going to rise again. And so in here, it could do a couple of different things. It can look like a parabola. It can do stuff like this. Well, missed that completely there. There you go. Quick fix. Again, this is just a random sketch there, but I just want to get the idea across that when you have an even power, look at how they end. They end in the same direction. In this case, they were both rising. Look at the degree here. The degree is odd. And when they're odd, look at how they end. This one was even. They end in the same direction. A degree of 2 is an even. And look, they ended in the same direction. They're either going to both go up or they're both going to head down. And so that's what we're looking at today. And in your classwork that you're going to be doing, you're going to be listing these things as well, and then making a determination of, well, how is it going to behave? How is it going to look on the left? How is it going to look on the right? The even and odd power is what's going to tell us. That's why the leading coefficient is the most important. Now, looking at the next page here of our notes, look at the question that they're asking. Decide whether the function is a polynomial function, and if it is, write it in standard form. Standard form just means descending order. That just means you go from the biggest power to the lowest power. It says, tell me the degree, tell me what kind it is, and then name the leading coefficient. They're going to want you to do the same thing on the homework. So when I look at the first one here, it says f of x is equal to negative 2x to the third, power of 3, power of 1, power of 0. So I don't see any fractions up there. I don't see any decimals. I don't see any negative powers. I know there's a negative here, but we're looking at powers only. So I don't see any of that. Well, because of that, we now know that yes, this is a polynomial. So yes, a polynomial. And now let's name everything they wanted. They said, all right, tell me the degree. Well, the degree, remember who calls the shots? The one with the biggest power calls the shots. And so that would be a degree of 3. They also said, well, what type is it? Well, because it's a power of 3, that means this is a cubic. That would be the official name. And finally, they said, well, tell me the leading coefficient. So the leading coefficient is a -2. And so that's what we're looking at. We're trying to describe, all right, well, what kind of function is it? What will happen with it? That's how we start all of our assignments, or you'll see in the homework and the classwork. All right, let's look at the second one. When I look at the second one over here, for g of x, all right, let's see. We're looking at powers only. So when I'm looking at my power here, I have a power of 3, a power of 4, and remember, this is technically a power 0 because there's no x there, so power 0, that's okay. All of these are whole numbers, no fractions, no decimals, no negatives. Then we're going to say yes, a polynomial. Okay. So now we can answer everything. The degree. Well, remember, they said they wanted it in standard form. I almost forgot there. Power of 3, power of 4. You see, that's the wrong order. So I do need to rewrite this. So I will rewrite it because the order is incorrect. The correct order should be the highest power first. And even if it has that weird radical 2, it doesn't matter. The x has a power of 4. This one would be next, negative 0.8 x to the third, and then the minus 12. And you see, now it's ready. This is the correct order. This is the one calling the shots. So that's why the degree is officially a 4. Next thing is, well, I have to name it. Well, according to our notes here, this is now a quartic. And finally, they said, well, what's the leading coefficient? Well, the leading coefficient is a square root of 2. It's a positive square root of 2, and that's okay. Luckily, we're not graphing that one of those, but there you go. All right, let's keep this thing going. So I look at this one now. It says h of x is equal to negative x squared plus 7x to the negative 1 plus 4x. We look at powers only. Again, only look at the powers first. And yes, there's an invisible 1 right here. But if you look at the powers on this one, look at that right there. We have a negative power. When we have that negative power, that's the first indicator that this is not a polynomial. If this is truly a polynomial, I should not have any fractions in my powers. I should not have any decimals, any radicals, right? And I should not have any negatives. This is what caused this not to be a polynomial. And that's it. I don't waste my time looking for all these details when it's not a polynomial. So in your homework today, if you get one that's not a polynomial, you really don't have to answer anything else. Even if they ask, well, what's the degree? What's the leading coefficient? You don't have to answer it if it's not a polynomial. Look at number 4. I look at my powers. That's the first thing I go to. Power of 2, power of x. Whoa, you see, we got to stop right there. We said our powers have to be positive whole numbers. Positive whole number, check. That's not even a number, right? Not a whole number. It's actually a variable, which means we don't waste our time doing anything else. Not a polynomial. And I move on. So be careful, because some people will start answering everything. Oh, the degree's this. And then they realize, wait a minute, it's not even a polynomial. I just wasted some time. So always check there first. We're always looking at powers. Even 0 powers. Remember, there's no x there. Now, the other thing they want you to do on today's assignment is they want you to evaluate polynomials. Now, when you evaluate polynomials, evaluation just means you're going to do one thing. You're going to plug in. That's it. Remember, we've done this plenty of times. They gave me this equation, and then they said, oh, by the way, x is equal to 3. Remember what we've said. If they give you a value, and they say, all right, do something, do some kind of math. Well, plug in because they gave us a number. So I'm going to do f of blank. Every time I see an x, I'm going to leave it blank. Again, don't worry about plugging anything in yet, because if you leave anything out, like the -7, the 5 that's right there next to it, then there goes the whole problem. We are plugging in x equals 3, or just the 3. Look at that. 1, 2, 3. We're basically doing this 4 times. And so they want to know, what is f of 3? Well, f of 3 means plug in a 3 in every blank space. So now I'm ready. Remember, I don't do anything with this. That's just part of the name. So 3 to the 4th, right? Times 2. Well, 3 to the 4th is 81, according to the calculator, minus 3 squared. Well, 3 squared is 29, sorry. 5 times 3 is 15, minus 7. Well, as you can see, we still have a lot of stuff that we have to do here. So now I need to multiply the 2 times the 81. And when we're doing 2 times 81, yes, the calculator is going to come in handy here. So 2 times 81, 162. 8 times 9, add the 15, minus 7. All right, here we go. So now we're going to use a calculator here. We want to make sure we have the right answer. So 162 minus 72 plus 15 minus 7. All right, just like that, I get an answer of 98, and there's my answer for f of 3. Now, don't forget what we just found. We technically just found a point. This, if I were graphing, this is the point 3, comma, 98. Okay? On big ideas, this is what they're going to ask you. They're going to say, tell me what f of 3 is. That just means plug it in. You don't have to rewrite it as a point. That's just for later. Okay? All right, look at number 6. Same situation. What they're asking for is, they said when x is equal to 4, they're asking what is f of 4 equal to. That's really what they're asking. This is what it's going to look like on your big ideas assignment. All right, so here we go again. Let's zoom in there so we can see it a little bit better. All right, here we go. F of blank is equal to negative. Now, notice how the negative is on the outside there. Don't forget that. The 3 something squared plus 9. So again, look how many spots we're going to plug into. And we're going to throw that 4 in there. So here comes the 4. So 4, 4, and 4. All right. So 4 to the 3rd is 64, but because there's a negative in front, then it is going to be negative 64. See, the negative is out there. That's why you have to use parentheses, especially with the calculator. 4 squared, 16, plus 9. All right, the negative 64 is still patiently waiting. The 3 times 16 is 48, so positive 48, plus 9. And let's see what we get here with the calculator on this one. All right, so negative 64 plus 48 plus 9. Just type it all in onto Desmos. And so I get an answer of negative 7. And there's f of 4. There's my answer. And like I said, if I were graphing, this would be the point 4 comma negative 7. Okay. Speaking of graphing, well, here we go. Now, when we're graphing, and again, this is where Desmos can come in handy for us here. We're going to be looking there. So it says graphing a polynomial function, and we're going to use a classic table method because this is our go-to. When we don't know what something looks like, this will be our go-to.